This recipe comes from a papyrus that was buried with its owner in Egypt sometime in the 3rd century, from 200 to 300 AD, making it at least over 1,700 years old. The papyrus, called the Leyden Papyrus X, probably came from somewhere in Thebes, the Egyptian Thebes, not the Greek Thebes. It was stolen from its resting site by grave robbers and sold on to a collector in the 1800s, only eventually making its way to Leiden University in the Netherlands, where it was first translated and researched. Because of this, the details of its discovery and exactly where or with whom it was buried are not known. The recipe is strikingly simple and highly refined, making use of only 3 ingredients, all of which are very common, and without any one of which the recipe will not work. Admittedly, the combination of these 3 ingredients is a little gross in practice and releases poisonous sulfur fumes. For me to do this safely, a well-ventilated environment and respirator rated for these fumes is a bare minimum. I imagine the Egyptian workshop that made this stuff would have had quite an odor to it. I really would not try this at home. Despite its off-putting fumes and strange ingredients, it's an elegant preparation and works just as described. Ominously, the papyrus tells us we've completed the recipe as soon as it begins to look a little like blood. Now watch as I dip this silver-plated spoon into the foul concoction. Wherever the solution touches the silver, the spoon is tarnished, a sort of glimmering golden color, almost as though the mysterious liquid has the Midas touch. This is the 89th recipe of the Leyden Papyrus X, just one of over 200 recipes contained within it and its sister, the Stockholm Papyrus, all with similar aims of imitating natural treasures. I've been working off of Earle Caley's translation of the Leyden and Stockholm Papyri, which is a dated translation but freely available online from the University of Cincinnati, with informative commentary from William B. Jensen, which I'll link to in the description. The liquid I've made here is called sulfur water, or possibly divine water, as the Greek word used, theon, means both sulfur and divine. Silversmiths in the audience might recognize it as the tarnish you get when you mix liver of sulfur with a little dilute ammonia, and like any other silver tarnish, it can be easily removed with a light abrasive. The author undoubtedly knew this, but they also knew most regular folk couldn't tell. The Stockholm Papyrus contains similar recipes for mimicking precious stones, like emeralds and rubies, and Pliny the Elder mentions this counterfeicy of nature in his natural histories, telling us that there is no other kind of fraud practiced by which larger profits are made. The traditions these recipes reflect were the beginnings of the craft of alchemy, the mysterious and greatly misunderstood art of transmutation. This recipe, along with many others across the history of alchemy, has been previously reproduced by Professor Lawerence Principe at Johns Hopkins University. Principe is a professor of both history and also organic chemistry at Johns Hopkins, and as you might imagine, his focus is the history of alchemy. I first learned of the Leyden Papyrus a number of years ago from Principe's phenomenal overview of alchemy, entitled The Secrets of Alchemy. If you're looking for a good book to read about the history of alchemy, there's none better to start with than this one. In this video, I'd like to explore the craft tradition of alchemy a little, and reproduce some alchemical processes to show how this arcane art worked and what it looked like. However, to really understand how alchemy worked, we have to try to get at its theoretical component too. How alchemists understood what they were doing, how they concocted their recipes, and made use of the art's fascinating abilities. This is an intimidating topic, as alchemy existed across millennia and went through a constant evolution of ideas and frameworks, of which we can only hope to scratch the surface of in this video. To start, I'd like to look at that recipe I just performed a little closer, and try to understand its context within the wider tradition. The Leyden and Stockholm papyri are the oldest artifact examples of writing associated with the Greek-Egyptian period of alchemy, centered around Egypt in the first millennium AD. It's called Greek-Egyptian because it was strongly influenced by the Greek culture of Egypt, introduced during its long rule by the Greek pharaohs of the Ptolemaic dynasty. For example, despite the fact that they were likely written by an Egyptian scribe, the Leyden and Stockholm papyri are written in the Greek language. Professor Principe suggests alchemy essentially arose out of an application of ancient Greek philosophy to ancient Egyptian craft traditions, and from the evidence I've seen, this certainly holds true. These papyri come about so early in the historical record that they are generally considered proto-alchemy, being that they lack many of the definitive theoretical ideas of the later alchemical traditions. There's no philosopher's stone at this point, nor is there really any clear underlying investigation of matter in these papyri. There's a few sparse references to theory that we'll get to in a minute, but for the most part it's essentially just a collection of recipes meant to mimic precious substances. This doesn't mean the author didn't have theories or wasn't interested in that kind of thing. We really can't jump to that conclusion. It's very likely that these papyri were intended to be used as a reference text for someone who already knows the workings of the field, essentially making it an Egyptian alchemical formulary, or book of recipes. You wouldn't really expect a formulary to explain to you the workings of nature. Because of this, if we want to actually learn how to do alchemy, we'll have to look elsewhere. The papyri have no original title, and list no author. We'd have basically nothing to go off of for where these recipes came from, if it weren't for one interesting exception. Recipe 2 of the Stockholm papyrus is otherwise much like the other recipes in the papyri, except that it references its source. It tells us the recipe came from Democritus and was transmitted through an axillus. This is undoubtedly a reference to the famous ancient Greek philosopher, Democritus of Abdera, the philosopher who developed Greek atomic theory. However, Democritus of Abdera never wrote about alchemy, and alchemical texts won't mention atomism for many centuries. It was a common practice at this period of time to write under the name of Democritus, pretending to be the famous Greek philosopher, spreading your work under their guise. The recipe in the papyri almost certainly came from a pseudo-Democritus. People attributing their work to the name of a famous figure is called a pseudepigraphic tradition, and the history of alchemy is filled with pseudepigraphic traditions. Only very rarely do alchemical authors ever write with their actual names, and oftentimes alchemists who belong to the same school of alchemy or who adhere to the same theoretical system will all write under the same name. This was especially true in the Islamic period of alchemy, where literally centuries worth of writing was all said to be written by one pivotal alchemist, Geber ibn Hayyan. At the time the Leyden papyrus was written, the pseudepigraphic tradition around Democritus was especially rich. It had concocted a popular narrative of the philosopher traveling to Egypt and the Near East, learning about magic and the secrets of nature from Persian magi, specifically the great sage Ostanes. Writing under the name Democritus this way was especially popular among people writing about magical topics. Richard Gurdon, who wrote Book 3 of the textbook Witchcraft and Magic in Europe, Ancient Greece and Rome, tells us that this pseudepigraphy around Democritus spawned a sort of natural magic tradition. Unlike some other forms of magic that source their power by invoking daemons or deities, this more natural magic was inherently based on the powers innate within nature and natural substances. Because of this pseudepigraphy, the Democritus mentioned in the papyrus could be pretty much anyone. Their real identity will probably always be a mystery. However, we have an interesting lead. Though the Leyden and Stockholm papyrus are the earliest artifact texts of the alchemical tradition, they're not the earliest known writing on the subject. This is a page from Marcianus Gracchus 299. It's a codex compiled by Byzantine scribes around the 11th century AD, and contains an assortment of copies of earlier Greek-Egyptian alchemical texts. some of which were originally authored before the Leyden and Stockholm papyrus. These aren't whole texts, just fragments the scribes chose to preserve, but what is preserved reflects the vast majority of our knowledge of early Greco-Egyptian alchemy. The earliest text preserved in the Codex is ascribed to none other than Democritus. It is entitled Physica Kai Mystica, which is Greek for something along the lines of natural and secret, which I have here, translated into English by Professor Matteo Martelli in his critical edition. Professor Martelli is a brilliant historian and has used the book's mineral terminology to date the original writing of the Physica Kai Mystica to around the 1st century AD, nearly 2,000 years ago, and he has suggested the author may have lived in the city of Alexandria in Egypt. This is one of the longest and most complete texts preserved in Marcianus Gracchus 299, though it's still missing some pieces. Its 4th book, on the making of precious stones, has been lost entirely. In my personal opinion, what remains of the Physica Kai Mystica might be one of the most fascinating texts ever written. On first glance, it appears much like the Leyden and Stockholm papyrus, a list of recipes. The techniques demonstrated are technologically similar to those in the Leyden papyrus and are undoubtedly from the same craft tradition. However, unlike the Leyden papyrus that gives very little in the way of underlying theory, the recipes in the Physica Kai Mystica are interrupted by the author's rants on the working of the art. It's in no way a textbook. This is clearly meant to be read by someone who already understands the craft, just as with the Leyden papyrus. But Pseudo-Democritus is enamored by the workings of nature and can't help himself from waxing lyrical about the beauty and power of his craft, all while dropping hints about how it works. He tells us not just that gold and silver and stones can be made this way, but that anything at all can be made through an understanding of this art. He takes it a step further and uses his art to make grand statements about the nature of the universe. He tells us that this art demonstrates that all things are in reality made of the same thing, claiming that the plurality of matter is an illusion, or that beneath all things there is one thing taking on different forms. This idea is essential to alchemy. It's what makes transmutation, or the changing of a substance's identity, possible, but it isn't original to Pseudo-Democritus. Greek philosophers had been toying with something along these lines for a long time, which the historian G.E.R. Lloyd covers in his book Early Greek Science, Thales to Aristotle. In it, he discusses the so-called problem of change, or how can one thing turn into another. Even some of the very early pre-Socratic philosophers had suggested there must be one underlying thing. Anaximander suggested that there must be some indefinite thing, he called boundless, that forms all other things. Later on, Aristotle had suggested an idea known as the proton ile, Greek for first matter, a notion later medieval alchemists would refer to in Latin as the prima materia. Finding and understanding the nature of this first matter would become known as an alchemical arcanum, a sort of goal for alchemists to achieve, amongst other arcanum like the closely related philosopher's stone. These strange rants are only a small piece of what the Physica Kai Mystica has to offer, and I'm definitely going to cover more of this book's contents in future videos. But because I want to get back to doing some practical alchemy before too long, I'd like to specifically focus on just one component of the Physica Kai Mystica for now, the makeup of substances. I should say, Pseudo-Democritus never calls this stuff alchemy. At this point in history, this craft had no name. A few hundred years after writing the Physica Kai Mystica, the alchemist Zoisimos of Panopolis, who directly references the Physica Kai Mystica in his work, would refer to the craft as chemia, which is our earliest known account of a name for the art. When the books on chemia made their way to the Islamic Empire, the Islamic practitioners added the Arabic article al, terming it alchemia. Then when alchemia made its way into medieval Europe, medieval European scribes mispronounced alchemia as alchemy. I mention all of this because this means Pseudo-Democritus can't just tell us he does alchemy. When he tells us what the book is about, he has to instead define the art. He tells us he strove to combine natures, or essentially to combine the qualities of substances. To Pseudo-Democritus, to make a desired substance, you search for the qualities of that substance scattered throughout nature, collect together substances that each reflect one or more of the desired qualities, and use the art to join them together into one substance in a way that maintains those desired qualities. To Pseudo-Democritus, gold isn't necessarily a distinct substance as much as it is a combination of the qualities that make it metallic, yellowish, flexible, fusible, and perhaps most importantly, noble, or resistant to fire. Base metals like lead are already metallic, so you just need to alter their other qualities until they match gold. His gold mimicking comes on a spectrum. The simplest recipes aren't meant to make gold as much as they're meant to just make a metal look yellow. More complex ones aim to imitate more of gold's qualities, and the most complex try to imitate gold's ability to resist fire without rusting. It's not at all clear if he thinks this means he's actually made gold, or if more so he sees his work as having overcome the undesirable or corrupt natures of base metals, making them more gold-like. It's important to recognize that these early Greco-Egyptian alchemists weren't underground criminals or anything, but more likely they were temple craftspeople and artisan priests, building off of older craft traditions. The way they categorized matter was heavily influenced by their artistic aims. One of the most striking differences between the Physica Kai Mystica and the Leyden papyrus is that the Leyden papyrus almost always specifies exactly what substance to use, whereas Pseudo-Democritus will oftentimes tell us to use any substance of a specific class. He's categorized his reagents based on how they act and the qualities they confer to matter. That sulfur water I made earlier, that's the kind of thing Pseudo-Democritus would call a yellowing medicine. Its whole purpose is to transfer a golden gleam to a substance, and it's just one of many yellowing agents at the artist's disposal. His coloring agents and processes seem to be divided into groups based on the ancient primary colors: black, white, yellow, and red. Just as painters could make whatever color they desired from a few pigments, Pseudo-Democritus tried to create a sort of palette of reagents for creating any desired substance. Pseudo-Democritus attempts to classify matter in a similar way to how I've seen painters categorize their pigments, or potters categorize their glazing minerals. These ideas almost certainly didn't originate with Pseudo-Democritus, but rose out of those long-standing craft traditions. Professor Shannon Grimes, in her book Becoming Gold, demonstrates the strong connections between Greek-Egyptian gold-making processes and Egyptian statue-making traditions, and in their article, Near Eastern Origins of Greco-Egyptian Alchemy, Maddalena Rumer and Matteo Martelli point out a clear connection between the stone-making recipes of the Stockholm papyrus and an earlier recipe found on a Babylonian clay tablet. It would seem the Greco-Egyptian alchemist was a multidisciplinary artist who aimed to unify the lessons of a diverse number of crafts, systematizing them to create a universal framework for manipulating matter. All of this is just to say that the theory of the Physica Kai Mystica and the alchemical tradition that evolved out of it rely heavily on the qualities or nature of a substance. So how do we go about understanding the nature of a substance? Pseudo-Democritus tells us in one rant that we must experimentally test our ingredients to understand their qualities. After all, he says elsewhere that some substances' true natures are hidden and only come out when joined to other substances. So we have to explore matter through experiment to learn how it acts. Interestingly, he says to do this the way physicians test their medicines to see if they are hot, cold, wet, or dry. This is a clear reference to the medical theory of his time, especially the four principal qualities of dry, hot, wet, and cold. These principles would be used in alchemy for centuries upon centuries. They're a crucial part of ancient Greek philosophy, especially in Aristotle's theory of elements, wherein each of the four elements, fire, water, air, and earth, is made up of two of the four qualities. Fire, which ascends, is hot and dry, and is represented by a triangle. Water, which descends, is cold and wet, and is represented by an inverted triangle. Air, which ascends, is hot and wet and is represented by a struck-through triangle. And earth, which descends, is cold and dry and is represented by an inverted struck-through triangle. The use of these four fundamental qualities in medicine goes back to the ancient Greek Hippocratic physicians, those following Hippocrates. The Hippocratic text, On the Nature of Man, describes the four bodily humors as each being composed of two of the primary qualities, mirroring the makeup of the Aristotelian elements. But they were used in all sorts of other fields as well. Aristotle uses the qualities and elements to describe the weather in his Meteorologies. The astronomer Ptolemy applied the qualities to each celestial body. The Greek philosopher Theophrastus uses the qualities to describe the makeup and behavior of minerals in his book on stones. It's really the use of these qualities in medicine and in mineralogy that would be the most influential to the history of alchemy. These four qualities can sound kind of silly, but in practice it's actually a much more developed system than first meets the eye. Hot, cold, wet, and dry were associated with those sensations, but also with a list of other physical qualities. For example, Theophrastus in his book on stones notes that any wet substance can melt, whereas a dry substance won't melt. Along with this, we can expect airy substances to be able to evaporate. Galen, a physician who lived shortly after Pseudo-Democritus, wrote that to understand the principles we have to use our senses to taste and touch and observe chemicals, both as they are but also as they combine with other substances. To explore this, I want to try to understand one of the ingredients in the sulfur water recipe from an alchemical perspective, specifically this white stone, quicklime. The Leyden and Stockholm papyri make it clear quicklime is a fiery substance, and interestingly states that the fire of quicklime is easily transmissible to other substances, a property the papyrus makes use of in multiple recipes. This is limestone, calcium carbonate, otherwise known as chalk, a white stone you're probably familiar with, as it can be found in one form or another pretty much anywhere on Earth's surface. The word chalk and the word calcium both come from the stone's old Latin name, calc. To make quicklime, we just have to roast this calc at a very high temperature, as I'm doing here with my old-school blowtorch, a tool alchemists made frequent use of from the Renaissance period onwards. A good sign the conversion is taking place is when the limestone begins to glow brilliantly in the intense heat. This incandescence is called limelight, and it can get astonishingly bright. Before electric lighting, limelight was used in theater spotlights. Lime won't really ever melt. It will just get hotter and hotter and glow brighter and brighter until its temperature reaches an equilibrium with the fire. Not being able to melt would make this a dry substance to Greek philosophers like Theophrastus. This process of roasting a substance in the open air came to be known as calcination, and the matter that remained after calcination was called the calx of that substance. As you might imagine, normally the calx would be some kind of ash. Calcination was typically done in a charcoal furnace, like the one I used to make the quicklime for the sulfur water earlier. Medieval alchemists called these furnaces of calcination calcinatories, and they were one of the alchemists' essential tools. Once removed from the fire and allowed to cool, the stone looks more or less the same. It's still just a chalky white lump. But watch what happens when I toss the stone into water. It instantly disintegrates. The stone almost certainly tastes very bitter now, though I'm not going to put it in my mouth, and I'll show you why. If I grind up a decent amount of this roasted lime into a powder, then carefully drip water onto the powder, you'll see that the water that touches it instantly boils into steam. This heat released is part of what makes quicklime fiery, and alchemists recognize that a similar heat could be found in pretty much any calx. The heat from lime is particularly intense, and with a little more water, the powder begins to smoke as the paper below it begins to smolder. Quicklime has been known to burn down buildings this way, and has always been notorious for causing fires. Not only does this substance become very hot, but it also becomes very caustic when mixed with water, and is able to cause chemical burns even when fully cool. If we have a fiery calx, how do we join that to another substance? What about this fiery element is transmissible, as the papyrus claims? To understand that, we have to understand how they thought elements could be joined together. A crucial component of this theory of elements and qualities is that opposite qualities are not mutually exclusive. A substance could be simultaneously earthly and airy, or even fiery and watery, based on what combination of physical qualities it has. Aristotle makes it clear many substances, including us humans and our mortal flesh, are some combination of all four elements. To explore this idea further, I'd like to jump forward to the medieval period. By the time the first alchemical manuscript to reach medieval Europe was translated from Arabic into Latin in 1144 AD, this basic theory for interpreting substances had already grown into a sophisticated and elegant practical system through its time in the hands of the Islamic alchemists, all of which hinged on essentially one crucial idea that dates back to our Greek philosophers, which I'll quote from the medieval natural philosopher Albertus Magnus in his Book of Minerals. It's the heat of the fire that brings together things of the same kind and separates things of different kinds. Essentially, fire can break apart a single substance into its constituents, and constituents of similar qualities are brought together. For example, the earthly things that make up a substance collect together in the ashes, the calx, whereas the airy things that make up a substance collect together in the smoke and vapors released, the spirits, to be collected by distillation. This ability of fire to abstract matter into its pieces enabled alchemy. This was the essential operating principle of Geber ibn Hayyan's alchemical school of thought, which drew off the Greek-Egyptian idea of all substances having a spirit and body, or pneuma and soma, that can be separated by fire. Islamic alchemists had figured out that the spirit and body could be broken down into subgroups by applying other alchemical processes meant to further isolate the principal qualities. For example, calcination can separate a calx from crude matter, but that calx can be further broken down through more processing into a dry, earthly calx and a wet, watery calx. This wet calx was called the salt. By the time alchemy made its way to the medieval Latin world, there were many such processes, though what those processes were differed at least slightly from one alchemical school to another. Just as many Islamic alchemists wrote under the name Geber, as soon as alchemy made its way into medieval Europe, European alchemists began writing under the name of Geber as well, contributing to the pseudepigraphic tradition around him. But of course, they totally mispronounced his name, leading to a distinct pseudepigraphic tradition around the name Geber, which contains some of the most essential European alchemical texts, such as the famous Summa Perfectionis, which I have here as a reprint of Richard Russell's 17th century translation, edited by Holmyard in the 20th century, though a much more recent translation and critical edition by Professor William Newman can be found on the Internet Archive, which I'll link to below. Geber's alchemy in the Summa Perfectionis hinges on 8 essential alchemical processes. These are calcination, distillation, sublimation, dissension, solution, coagulation, fixation, and ceration. 4 of these processes, calcination and distillation, sublimation and coagulation, seem to be about separating elements or qualities, while the other 4 seem to be about combining them. These processes were clearly a development of the Islamic period, and the Islamic alchemist al-Razi lists 7 similar processes in his Kitab al-Asrar, or Book of Secrets. For him, calcination and distillation were combined into a single process of purification. Each alchemical process targeted either a particular quality or set of qualities to be isolated or joined, and each process can also be broken down into subcategories. Looking at each one of those in close detail will have to be the subject of a series of videos, rather than just this one. For now, I want to look at how this theory could join together opposite elements, like air and earth or fire and water. This is salammoniac, a powder of snowy white crystals. Salammoniac gets its name from its home, the Kingdom of Ammon, where it could be found naturally in the kingdom's deserts. Medieval alchemists learned how to make it themselves, however. Geber's Invention of Verity contains a recipe for salammoniac that uses, of all things, urine and human sweat. Chemically speaking, that should work, but I just made this sample using modern chemistry in my lab, partially just because I have no idea how they harvested that much sweat. Watch what happens when I heat some of the crystals in the flame of a blowtorch. Rather than melting like snow or glowing like quicklime, the much more mischievous salammoniac vanishes into a vapor and flies away. Being able to evaporate makes this substance a spirit, but alchemists recognized that this spirit wasn't being separated from the salt, but that the spirit actually was the salt. By holding a smaller vial of ice water within the test tube, I can condense the vapor back into a salt on the walls of the cold tube. The salammoniac has reformed, just as it was before. Because it condenses as a solid instead of a liquid, I have to scrape it off to collect it. This process of evaporating and condensing a solid is what the alchemists called sublimation, which they typically performed in something called an aludel. Because salammoniac doesn't melt, this fits the definition of a dry substance, but because it evaporates, it's airy, which requires it to be hot and wet. A strange contradiction, but nonetheless still real and something alchemical theory had to contend with. However, instead of ignoring this exception, alchemists embraced this exception. In the Summa Perfectionis, Geber heralds sublimation as one of the most crucial alchemical processes, which he says isolates the dry spirits. Not only could contradictory elements exist together in nature, but because alchemists could make things like salammoniac themselves, they knew they could combine them synthetically. Similarly, the alchemical processes should allow us to join the fire of our quicklime to the wet principle of something else, to make a simultaneously fiery and watery transmutation agent. There are many alchemical recipes for this type of substance, including one in the Stockholm Papyrus. But I'm going to go off a recipe in the medieval alchemical manuscript known as the Libellus de Alchemia, or Little Book of Alchemy, a favorite of mine, written by Pseudo-Albertus Magnus, which I have here translated by Virginia Hines. To start, we need ashes. The book specifies a few different kinds of ashes we can use, but the most common is wood ash, so that's where I'll start. By burning wood to ash, we essentially calcine it. However, unlike the calx of limestone that is entirely earthly, being unable to melt or dissolve, alchemists recognized that the ash of wood was a mixture of different calxes, some of which were just as earthly as lime, and some that were a little more watery and could be readily dissolved into water. As I mentioned earlier, to alchemists, a water-soluble calx was called a salt, with the insoluble calx being the true calx that epitomized earthliness. To isolate the salt from this ash, I have to make use of its affinity for water and dissolve it, then use filtration to isolate the solution from the insoluble earthly calx. This combined process of dissolution and filtration was known as lixiviation. You'll notice my filter here isn't a funnel. Alchemists did use funnels too, but these filters made by draping a towel over the edge of a vessel pop up a lot in medieval depictions of alchemists, so I thought I'd give it a go for this lixiviation. Once filtered, I'm left with a crude yellow lixivium of ash. The next step is to coagulate this solution, which just means to evaporate it back into a solid. The yellow color indicates there's quite a number of impurities, and sure enough, when coagulated I'm left with a yucky brown powder. This salt was called potash, because it was collected from ashes dissolved in pots of water. There's a sort of popular myth that alchemists thought yellow contaminants were good, as they looked golden, but that's mostly just made up. Even as early as the Physica Kai Mystica, such impurities were seen as just that, impurities. And Pseudo-Democritus tells us that if a solution turns yellow when it's not supposed to, that we've messed up. Certainly, alchemists thought color changes were important, and many believed there to be a specific sequence of color changes in the process of making the Philosopher's Stone. But that was specifically for the preparation of the Philosopher's Stone, and in any other recipe, the color most alchemists will be going for is based on what they expect from the process. For example, the Libellus de Alchemia tells us we're going for a white powder in this recipe, so I'm going to have to purify this potash I've prepared here, as to avoid disgrace. Unlike today, where I might do this with recrystallization or even just by filtering through some activated carbon, the alchemists preferred to absolutely annihilate their impurities and wipe them out of existence. If they thought something was impure, they liked to throw it in a crucible and calcify it with intense heat. They called this intense fire ignition, and it was one of the most severe torments you could give a substance. Alchemists actually invented the word crucible, which means little crucifier, to reflect the torment of the calcined body within it. After a while, you can see the powder is beginning to whiten, but is also starting to clump together, almost as though it wants to melt, but just can't quite. After a good deal more roasting, I'm left with a substantially whiter salt. Now I just weigh my potash to determine how much I have to work with. This lixivial salt is the wet substance I need to join to quicklime. The recipe recommends a specific proportion of ingredients, so next I weighed some freshly prepared quicklime to the proportion the recipe recommends. Then I just ground the two ingredients together to get them nicely mixed. The next day, I dissolved the mixture in water, resulting in a nice clear solution with a chalky sediment. Now I just have to filter this solution to remove the sediment, which I did with a regular funnel this time due to the small volume of water. Once filtered, I have to boil down the solution to a powder. I'm doing this in a steel vessel rather than a glass one, because though it may not look as though much has changed, what we've created here is actually an incredibly potent solvent, and will dissolve the glass of the beaker if I'm not careful. After coagulating the solution, I'm left with a sort of gross brown powder again, and yet again I'm just going to have to calcine the stuff to be rid of this feculent corruption, as alchemists would say. This time I'm going to use a silver crucible, whose nobility will be able to withstand the fiery element within this salt. This time I'll also use my Renaissance blowtorch to calcine the salt. As I go, I'm going to carefully add a drop of water and allow the water to evaporate until I'm left with a white salt. Again, don't try this at home. Along with glass, this salt will happily dissolve human flesh. Once I've got it where I want it, I bathed it directly in the flame of the blowtorch. As you can see, the salt began to redden and flow together like candle wax, just as the recipe describes. Seeing the substance melt like this tells me I've succeeded at my goal. The fiery calx has become a watery substance that can melt and dissolve. The combination of the corrosive fire of quicklime with the watery nature of potash. Because it's made out of calcined ashes, the Islamic alchemists named it calcined ash, which in Arabic was alkali. There were two main kinds of alkali. This kind, made of potash, was called potash alkali by medieval alchemists, but another kind was made specifically from a plant that grows in salt water, a plant known as soa. Of course, as always, the European alchemists mispronounced soa as soda, and so they called the alkali made from it soda alkali. You'll notice I've only made a little alkali, even though I started with quite a lot of ashes. To make a useful quantity of alkali this way, I'd have to process a whole lot more ashes. Back in the day, when every facet of life relied on fire, ashes were easier to come by. However, even then, alchemists had a trick up their sleeves to make the process much more effective. Rather than starting with wood ash, the Libellus de Alchemia tells us we can instead calcine this stuff. This is tartar. You probably know it as cream of tartar, which is commonly used in baking. It typically comes from grapes, forming as a crystal in grape juice. Vineyards end up with quite a bit of this stuff. Alchemists made great use of tartar, and the humble powder would actually end up being instrumental in overturning some of Aristotle's theories in the 1500s, as well as being instrumental in the formation of acid-base theory in the 1600s. However, for now, we're going to ignore all of that and throw it in the crucible to face ignition. As you can see, unlike potash, tartar releases fumes when heated. This is what alchemists would call a spirit. It's crucial to do this in a very well-ventilated environment, where the fumes can be quickly extracted, as these fumes can easily catch fire, as demonstrated here. This was considered evidence of a fiery element within a spirit. As you might imagine, alchemists were famous for exploding, and personally, I don't want to end up remembered like that. That said, I think this is a really good example of how calcination can separate a calx from a spirit. You'll notice the tartar is melting and undulating like a fluid. Alchemists could use a process called dissension to isolate fluids like this, which in this case was called the oil of tartar. However, for now, I'm going to keep roasting until the fluid resolidifies and burns down to ash. The resultant calx takes the form of fused lumps. They look a little like pebbles. Now I have to extract the salt from this calx. Just like with the wood ash, the salt is extracted by dissolving the calx into water. This is where tartar shows its secret. Unlike wood ash, where only a small amount of the calx dissolved, with tartar, everything but the soot and carbon dissolves. The entirety of the calx is a watery salt, kind of like it's the opposite of how the entirety of the quicklime was a dry earth. To clear away the soot, I filtered my salt of tartar. The salt has a corrosiveness to it, but it's not yet as potent as quicklime. So to make sal alkali, I just have to combine it with some fresh quicklime, which produces a cloudy sediment. This sediment is filtered off, and then I coagulate the solution in a sand bath with a steel dish, and am left with a nice little pile of sal alkali. Though this is still just a small amount, bear in mind that I started with just a spoonful and a half or so of cream of tartar, as opposed to the full bowl of ashes required for a similar quantity of regular potash alkali. Just like last time, this alkali can be easily melted in the heat of a blowtorch, fusing together to create a waxy molten salt. This alkali is a potent solvent. I'm melting it in silver because it's able to dissolve glass and sand and clay and most other things crucibles are made of. Along with this, it can lower the melting point of sand by acting as a flux, which is why ash is used in glassmaking. Albertus Magnus, in his Book of Minerals, claims that alchemists are able to melt stones by adding wet substances to them, which is likely a reference to this fluxing ability of watery ashes. Though I may be wrong, to me this seems to suggest alkali was seen as transmitting its wateriness, a little like how the Stockholm papyrus claimed quicklime could transmit its fieriness. So what is this alkali from a modern chemical perspective? This potash alkali is a mixture of quite a few things, including some potassium chloride, along with some potassium carbonate, but mostly it's the all-important potassium hydroxide. The salt of tartar alkali should be mostly potassium hydroxide, with some potassium carbonates mixed in. If you've heard that fruit is high in potassium, this is the potassium they're talking about. Potassium is a metal no one knew existed until 1807. In the 1700s, chemists like Antoine Lavoisier had began to theorize it might exist, but it wasn't until after the invention of the battery by Alessandro Volta that potassium metal was first isolated by Sir Humphrey Davy. Davy ran electricity through molten potash alkali. Apparently, when he did this, it burst into flames. However, he says when he reversed the polarity of the circuit, he was able to isolate what he called the peculiar inflammable principle, the basis of potash, which he named potassium, after potash. What a clever cookie was he. Then he tried the same experiment with soda alkali and isolated a different metal he called ytterbium. I'm kidding, he called it sodium. These became known as the alkali metals. He also tried the same experiment on quicklime, but it was much harder. Quicklime, being earthly, doesn't melt, and Davy noticed electricity could only pass through the alkali when it was molten. Eventually, Davy's contemporaries, Jeans Jacob Berzelius and Magnus Martin af Pontin, beat him to it by using a technique involving mercury to isolate the metal from quicklime, which Davy termed calcium. Calcium, along with the metals isolated from other earthly substances, make up the alkaline earths on the periodic table. Yes, believe it or not, they are actually called earths in reference to the elemental theory alchemists used before the periodic table. Alkali compounds are normally more soluble and easier to melt than earth metal compounds, primarily because the alkali metals are much more likely to form polar salts than earth metals are. Because water is polar, these polar salts have a greater affinity for water. Despite having no way of knowing this, alchemists had still managed to sort matter into extremely useful categories, just by observing how nature transformed. Interestingly, Sir Humphrey Davy also tried to isolate a metal from ammoniacal compounds, like sal ammoniac and ammonia solution. He was so sure he could, he named the metal he thought he'd find ammonium. However, according to his entry in the Philosophical Transactions, he was unable to isolate it. The mischievous and elusive ammonia just kept turning into nitrogen and hydrogen gas. We know today there is no ammonium metal. Nitrogen and hydrogen just combine in such a way as to imitate the way metals form ions. This was so perplexing to Davy, he suggested that maybe nitrogen and hydrogen themselves are actually metals. Just as Greco-Egyptian alchemists were able to convince people they had made gold when they hadn't, nature had pulled one over on Davy, convincing the poor chemist that metals existed where they didn't. This is what I love about alchemy. Just as Pseudo-Democritus says, these substances when dissolved produce everything. If you ask me, even if there's something they can't make, they can come so close you'll never tell the difference. Nature is a tricky and mysterious thing. Even though humanity had no idea potassium even existed for millennia, potassium has always been there. If you look closely at this alkali in the flame of the spirit lamp, you'll see it has a sort of lilac glow to it. This is the spectral emission of potassium. Each element's spectral emission is unique to it, a little like a signature, the element's true name written in light itself. Believe it or not, I've been intentionally showing you potassium's spectral glow throughout this whole video. Here it is in the ethereal flame of the charcoal furnace. The lilac color of this charcoal flame is caused by the potassium within the ashes that have yet to form. Even though humans wouldn't see potassium metal with their own eyes until the 1800s, we've been seeing its name amongst embers ever since the invention of fire. Thanks for watching. I'm going to end this video here, even though there's much more to be said about the craft of alchemy. We haven't even had a chance to talk about how they thought the metals formed, or how they thought the Philosopher's Stone could be made, or about all the wonderful things they could do with human hair. There will definitely be more videos on alchemy coming to this channel, hopefully sooner than later. But in the meantime, I'm going to link in the description to some other great videos and lectures on alchemy that can be found right here on YouTube. If you're interested in learning more about alchemical theory, Dr. Justin Sledge over on the channel Esoterica has recently released a phenomenal video on the elemental theory in Aristotle's Meteorologies that does a really good job explaining alchemical theory. If you're curious about what happened to alchemy after the 1700s, there's some fantastic lectures folks have uploaded by Lawerence Principe himself, which I'll link to as well. If, like me, you find yourself enamored by Greek-Egyptian alchemy, I'll link to a lecture by Matteo Martelli on the subject. I had a ton of fun making this, and I hope to have some more videos on alchemy and other old crafts sooner than later. So if you've enjoyed this video, please subscribe. If you know anyone who you think would enjoy this video, you'd be doing me a solid to share it with them. Your guys' feedback is invaluable to me, and is always really helpful in making these videos. So if you have any questions, comments, or corrections, please feel free to comment below. Thanks again, and happy transmuting!